Good evening, children.
Good evening.
Good evening.
Good evening. All right. So today's topic is probability. So first we'll discuss the outcomes when a coin is tossed once, a coin is tossed once, a coin is tossed 2 times, 3 times, 4 times. One coin tossed once, one coin tossed 2 times. That is one after the other. You toss it once and then you toss it again. One coin tossed 3 times, one coin tossed 4 times. Now, this is the same as tossing a coin 2 times, 3 times, 4 times is the same as tossing 2 coins once, 3 coins once, 4 coins once. See, if you have only one coin, tossing that coin 4 times, you have only one coin. So you toss it once, you note the outcome. You toss it the second time, note the outcome. Toss it the third time, note the outcome. Toss it the fourth time, note the outcome. So say first time H, then T, then H, and then again H. Now this is the same as having 4 coins and tossing all of them at the same time and recording the outcomes. If you have 4 coins, you toss them simultaneously. Okay, so you toss the 4 coins simultaneously, and when the coins land, you note the outcomes. Both are the same. Tossing one coin 4 times is the same as tossing 4 coins once. Tossing 3 coins. 1 second, children. Yeah. So tossing one coin 3 times. You have only one coin, so you toss it. Once, record the outcome. Second time, record the outcome. Third time, record the outcome. You have only one coin, so you have to toss it 3 times. It's the same as you have 3 coins and you toss all the coins at once and record the outcomes. So tossing one coin two times, the outcomes you get, the outcomes or the sample space, all the possible outcomes, which is also called the sample space, on tossing one coin 2 times is the same as the sample space you would get or all the outcomes you would get by tossing 2 coins once. One coin 3 times, sample space same as 3 coins once. One coin 4 times, sample space same as tossing 4 coins at once. So now we'll see the sample space. Now you know the sample space when you toss a coin. On tossing a coin, the sample space on tossing a coin is when you toss a coin, the coin can show H or T, that is heads or tails. So this is once. When you toss a coin, the coin can show heads or tails. Now when you toss the coin 2 times, all right. So to understand the sample space, write this 2 times. Okay, HT. Write it 2 times. Write it 2 times. HT. Write it 2 times. Fix a H. Fix a T. HH. HT. TH. TT. Now a coin 3 times. Thrice. See, what do we understand from the sample space? When you toss one coin 2 times. Okay, so the outcomes can be HH. First time H, second time also H, or first time H, second time tails. First time T, second time H, or both the times T. Three times. Write this 2 times. Any order. Any order. Write all these outcomes. HH, HT, TH, TT. Any order. Okay, write these outcomes. So I've written HH, TH, HT, TT. Fix a H. Fix a H. Fix a T. These are the outcomes. So the sample space, the number of outcomes when you toss a coin once is 2 to the power 1, 2. 2 times 2 square, 4. 3 times 2 cubed, 8. So 4 times it should be 16. So write all these 2 times. H, H, H. T, H, H. H, T, H. T, T, H. H, H, T. T, H, T. H, T, T. T, T, T. Now fix H to the first row. And T to the second row. Or you can fix T to the first row and H to the second row. So when you toss one coin 4 times, you can get any one of these 4 outcomes. When you toss one coin 4 times, you can get any one of these 4 outcomes. You will not get all these outcomes at the same time. What do we understand from the sample space? The last one. When we toss one coin 4 times, the outcomes, the possible outcomes you can have are this or this or this or this one or this one or this one or this like that. You can get any one of these 16 outcomes. We'll not get all the 16 outcomes. When we toss one coin 4 times or we toss 4 coins once, we can get any one of these 16 outcomes, any one of these 16 outcomes. So these are the possible outcomes when you toss 4 coins once or one coin 4 times. Same thing here, same explanation for these. So when you toss 3 coins simultaneously, or you toss one coin 3 times, you can get any one of these 8 outcomes. Any one of these 8 outcomes. So on the 3 coins, The outcomes can be this one or this one or this or this or this or this or this or this. Any one of these 8 outcomes. Yeah, please make a note of this, children. You don't have to show this tree. You don't have to show this tree, children. You don't have to take this. If you want to take a screenshot, I'll just take it. Please write down this. Please write down these. I think here the outcomes are not in the order I had explained now, so I think I'll write it. You can take it from here, children. Or maybe I'll just write it once again. It's not in the order I explained, so I'll just write it now. You can write it along with me now. So for 3 times, write this 2 times, write the earlier outcome 2 times. So see here, HH, HT, TH, TT. Write it once again, HH, HT, TH, TT. To generate the sample space for this one, write the earlier sample space 2 times. Write the sample space 2 times. HH, HT, TH, TT. Write it 2 times in 2 rows. To the first row, H. To the second row, T. So now write the earlier sample space 2 times in 2 rows. H, H, H. Any order does not matter, any order. Done, children?
Yes, ma'am.
All right. Yeah, please try this one. The probability is it's a fraction, and the value of the fraction can be 0 if it's an impossible event. It can be 1 if it's a sure event.
Ma'am, I think we've discussed this question already in our previous probability sessions, ma'am.
Oh, really?
Yes, ma'am.
Thank you, yeah. Yeah, what about this one? Any idea, Madhumita? No, I don't think. Okay.
No, ma'am, we haven't done this.
Yeah. I'll just come back till in 2 minutes. Please try this one. Though this question is not based on coins, please try this. I'll just come back. Yeah, children. All right. So before we discuss the answers to these questions, let's understand, more about the outcomes when two dice are thrown simultaneously or one die is thrown two times. The sample space or the outcomes we get when one die is thrown two times or two dice thrown simultaneously is the same. Throwing one die two times or two dice once is the sample space is the same. The possible outcomes are the same. Now, just see the outcomes along the diagonal. See the outcomes along the diagonal. So along the diagonal, the outcomes are a doublet. You get the same number 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Meaning both the dice show the same number. Now look at the outcomes below the diagonal and above the diagonal. So in all, there are 36 outcomes. In all, there are 36 outcomes minus 6 outcomes along the diagonal, which are doublets. So 36 minus 6, 30. So you have 15 outcomes below the diagonal, 15 outcomes above the diagonal. In all, there are 36 outcomes, 6 outcomes along the diagonal. And along the diagonal, we see that the along this diagonal, we see that the outcomes are doublets. So 36 minus 6, 30 by 2, 15. So we have 15 outcomes below the diagonal, 15 outcomes above the diagonal. Now look at the outcomes below the diagonal. Everywhere you see that the first number is greater than the second number. And above the diagonal, you see that the first number is smaller than the second number. So if you call the outcomes A comma B or X comma Y, okay, if you write the outcomes as an ordered pair, A comma B, A comma B, so the probability of having an outcome where A equal to B is 6 by 36 or 1 by 6. Probability that the outcome that in the the ordered pair which you get in the outcome is of the form A greater than B is 15 by 36. A less than B is also 15 by 36. So this can be reduced, right? 5s are 5 by 6. Not 5 by 6, sorry. Yeah. You could just make a note of this.
Completed, ma'am.
Yeah. Yeah, let's see the answers. I hope all of you made a note of this one. Sometimes the question also can be like this, probability that A by B is less than 1. A by B greater than 1. A by B equal to 1. The question can also be like this. So when you look at these outcomes as ordered pairs of the form A comma B, A by B less than 1. So if you see the outcomes above the diagonal, A by B is less than 1 because it will always be an improper, proper fraction. Look at the outcomes above the diagonal. Above the diagonal, you can see that A by B is a proper fraction. Proper fraction. So its value will be less than 1. Look at the outcomes above the diagonal. See the outcomes in the form A by B. 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 2 by 3, 2 by 4, 2 by 5, 2 by 6, 3 by 4, 3 by 5, 3 by 6, 4 by 5, 4 by 6. All proper fractions. So the value is less than 1. Probability 15 outcomes out of 36. A by B greater than 1. So the fraction should be an improper fraction. So look at the outcomes below the diagonal. 2 by 1, 3 by 1, 3 by 2, 4 by 1, 4 by 2, 4 by 3. So you will see that the values here, the fractions are improper fractions, meaning the numerator is greater than the denominator. So the value will be more than 1. Probability 15 outcomes out of 36. A by B equal to 1 represents the doublets along the diagonal. So 6 by 36. 1 by 6. Please reduce it always. Okay. Yeah, children. Let's see these answers. 3 will not come up on either of them. 3 will not come up on either of them. So what is favorable for, see, in the numerator, you must show the number of outcomes that are favorable to the happening of the event. Numerator represents number of outcomes favorable to the happening of that event. And the denominator is the total number of events or the total number of outcomes. So of these 36 outcomes, how many outcomes are favorable to 3 not coming up on either of them? How many?
11, ma'am.
All of you?
Ma'am, 25, ma'am.
25, huh? Navya?
Yes, ma'am.
25, okay. Yeah, others share your answers. What do we mean by 3 will not come up? 3 will not come up on either of them and neither of them. 3 will not come up on either of them and neither of them.
Ma'am, on both the dices, 3 should not be there.
That is for either or neither.
Ma'am, both, ma'am.
No, because there's a difference in the answers. So I'm just waiting for the others also to. Yeah, others. Is there a difference between 3 will not come up on either of them and neither of them?
Ma'am, either means either in one or two, in any one of them, and neither means in both the dice.
Correct. 3 will not come up on either of them. Either of them meaning one of them. Neither of them meaning
In
so
both
count
of
and
them.
both of them. Yes. So count now, children. Either of them.
10 by 36, ma'am. 5 by 18.
So is this a favorable outcome? 1, 3.
Yes, ma'am.
This one?
No, ma'am.
So 1, 2, 3, only these? No, this is a tricky one. That's why I'm pausing.
No, ma'am. We can take everything except 3, 3, ma'am. Every pair with the number 3.
Navya, what's your take?
Ma'am, I'm not able to understand.
Nice. Oh. Because this is just English there. Maybe we'll see all the answers and come back to that where we'll see if you have an idea. Tell me the second one. After 6, we'll come back to 1. Yeah, 3 will not. 3 will come up on at least 1. 3 will come up on at least 1.
Ma'am, 11 by 20, 11 by 36.
At least 1 meaning 1 or both. 3 will come up on at least 1. At least 1 meaning? At least 1 meaning 1 or both. See, if you say, give me at least 1 chocolate. At least 1 chocolate meaning you'll be happy if you get 2, 3, 4, 5. Any number. You want at least 1. Minimum 1. Give me at least 1. Give me minimum 1. So 3 will come up on at least 1. At least 1 meaning 1 or both. So see here, at least 1. 1 or both. 1 or both. 1 or both. 1 or both. 1, 1, 1. 3 will come up on at least 1. At least 1 meaning minimum 1. At least 1 3. You'll be happy if both are 3s. At least 1 3. So at least 1 3 meaning 1 3 or both 3s. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct?
Yes, ma'am.
So probability that 3 will come up on at least 1 is equal to 10 by 36. I hope I counted it correctly. 5 by 18.
Mom, it's 11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, okay. Please help me. 11. So then it's 11 by 36. Yeah, next one. 3 will come up on at least one. No, did we? Oh, sorry, we just finished that. I'm so sorry. It will be a doublet of prime numbers. Doublet of prime numbers.
3 by 36, ma'am.
Mom, 4 by 36, Mom.
Okay, so doublet of, it should be a doublet and of prime numbers. 1, 1 is a doublet, but not of prime numbers. 2, 2 is a doublet of prime numbers. 3, 3 is a doublet of prime numbers. 4, 4 is a doublet, but not of prime numbers. 5, 5 is a doublet of prime numbers. 6, 6 is a doublet, but not of prime numbers. So how many children? It should be a doublet. Yeah. So it should be a doublet, but of prime numbers. So doublets, we have only these 6. 1, 1, 2, 2, 3, 3. We have only these 6 doublets. And of these doublets, it should be a doublet of prime numbers. So 1 is not a prime number. 1 is neither prime nor composite. So it's 3 by 36 or 1 by 12. Yes or no, children? See, if anybody disagrees, please ask me. Let's discuss. Is it fine with all?
Yes, ma'am.
Okay. Next. All right. No, I don't know who said 3, who said 4, but I hope it's clear to all of us. Somebody said 3, somebody said 4. I didn't notice that, but I hope it's clear now. Next one. 3 will come up at least once. So at least once meaning once or both the times. So it's the same as the second one, right?
11 by 36.
Yeah. Neither 9 nor 11 as the sum of the numbers on the faces. Neither 9 nor 11. So you should not, you don't want some 9 or some 11. It can be anything else. But you don't want a sum 9 or 11. Neither 9 nor 11 as the sum of the numbers on the faces. See, yeah. See, what you should count is what you want, that you should count, not what you don't want. The numerator represents the number of outcomes favorable to the happening of the event. Favorable, not unfavorable. You must count the number of favorable outcomes divided by the total number of outcomes. The numerator shows the number of favorable outcomes, not unfavorable outcomes. Neither 9 nor 11 as the sum of the numbers on the faces. So you don't want some 9, you don't want some 11. You don't want these two, so you want the others, but you don't want these two. So where you get these, leave them and take the others. Okay, so here the sum is, it's not 9 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Can we take this one? No.
No, ma'am.
No. No.
Ma'am, or can we count the favorable outcomes and subtract that?
Yeah, correct. Yeah. So how many have we crossed? 1, 2, 3, 4, 5, 6, right?
Yes, ma'am.
So 30 by. So these 6 outcomes you don't want. You don't want some 9. You don't want some 11. So 6 outcomes. In 6 outcomes, you have some 9 or 11. But you don't want them. So don't write that in the numerator. Count the number of outcomes that are favorable to you. Write that in the numerator. Write what you want, not what you don't want. You don't want 9, you don't want 11. So 6 outcomes have some 9 or 11. So leave them. The remaining you want. So favorable will be 30 by 6 you don't want. So 36 minus 6, 30 you want. Yeah, you will be happy with any one of these 30 outcomes. So 30 by 36 or 5 by 6. Three will come up exactly one time.
Ma'am, 10 by 36.
Same, ma'am. 10 by 36.
Okay. So exactly once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? One second, my Xpen is not writing. Just a minute, children. My pen tablet is just give me 1 second. Yeah, sorry, children, I'm back. The tip of the stylus pen had got inside. I was not able to doodle, meaning write. I'm sorry, yeah. So I think we were in the sixth one. 3 will come up exactly one time. Did we discuss that, children? 3 will come up exactly one time.
Yes, ma'am. It's 7 by 36.
Okay, we finished that. So coming back to the first one, 3 will not come up on, let's not have taken a long time for you today. Okay, so 3 will not come up on either of them. Remember, either of them meaning both of them. Either of them meaning both of them. Either of them meaning both of them. 3 will not, remember this, 3 will not come up on both of them. So in how many outcomes 3 doesn't come on both?
11, ma'am.
See that you 3 should not come on both of them. So how much?
25, ma'am.
25, ma'am.
Ma'am, 25.
25 out of 36. So where all do you get 3? 1. Can see 3. Wait, children, just a minute. Yeah. Okay, so here 1, 2, 3 should not come up on both of them. So you should not find 3 in the outcome at all. Either of them meaning both of them. I just told you. So you should not find 3 at all in the outcome. So 1, 1, 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 3 will not come up on either of them, meaning on both of them. You should not find 3 at all. In the ordered pair, you should not have 3. So 25 by 36. 25 by 36.
Ma'am, that is what I said, ma'am.
Oh, okay. One of you, I don't know. One of you said 11, one of you said 25. Okay. Yeah, I think this we just discussed, no? You can write the answer to this. Yeah, please write down the question and complete this one. So the sample space here is similar to that of throwing a dice 2 times. Because you spin it, A is the number of the sector where the arrow stops after the first spin. And B is the number of the sector where the arrow stops after the second spin. So you spin this, you're allowed to spin this disc 2 times. You spin it once, record the outcome, spin it again, record the outcome. A is the number of the sector where the arrow stops after the first spin, and B is the number on the sector where the arrow stops after the second spin. So since there are 6 numbers, the outcomes will be similar to that of throwing a die 2 times or throwing 2 dice once. 36 outcomes. So A by B less than 1, 15 by 36. A by B equal to 1, 6 by 36. A by B greater than 1, 15 by 36.
Completed, ma'am.
Yeah. All of you?
Completed, ma'am.
All right. Next one. A and B are friends in the year 2020. What is the probability that both will have the same birthday, different birthdays? Are the probabilities the same as for the year 2019? So now it's not possible to write the sample space, but we can understand the sample space. It's not possible to write the sample space for this situation, but it's easy to understand the sample space. So let's understand the sample space. There are 2 friends. So let's start like this. A's birthday falls on 1st January. B's birthday also falls on 1st January. With A's birthday fixed on 1st Jan, you can keep changing for the second one, 2nd Jan. With A's birthday on 1st Jan, B's birthday can be on 3rd Jan. So like this, you can go on up to 1st Jan, 31st Jan. The first one represents the day on which A celebrates his birthday. The second one, B, on which the day on which B celebrates his birthday. So I have fixed A's birthday on 1st Jan. I have fixed A's birthday on 1st Jan. With A's birthday on 1st Jan, B can celebrate his birthday on 1st Jan, 2nd Jan, 3rd Jan till 31st Jan. So again, we'll fix A's birthday on 2nd Jan. With this one, B can celebrate his birthday on any day from 1st Jan to 31st Jan. Let me just write a few, you can understand. We'll fix A's birthday on 3rd Jan. With 3rd Jan, B can celebrate on 1st Jan, 2nd Jan,
Ma'am, should we write all this in the exam?
No.
Okay.
Not at all. You don't have to mention anything about the sample space. So like this, 31st Jan, 1st Jan, 31st Jan, 2nd Jan, 31st Jan, 3rd Jan, 31st Jan, 31st Jan. Then like this, you'll have, now this is 2020, right? So February will have 1 day extra, 29 or 28. Leap year has
29.
ma'am.
Yeah. So like this, it will go on till 31st December, 1st December, 31st December, 2nd December. So if you fix A's birthday on 1st Jan, B can have his birthday on 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, 5th Jan till 31st Jan. So like this, here you have 31 outcomes. Then fix A's birthday on 2nd Jan. With 2nd Jan as A's birthday, you can have B's birthday on 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, so on till 31st Jan. So again, another 31 outcomes. So you can imagine in the month of January, 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, so till like that, 31st Jan. So you'll have 31 rows like this, right? Same for February, same for March. So which means the total number of outcomes, if it's a leap year, the total number of outcomes will be, there are 366 days into 366. These will be the total number of outcomes. 366 into 366, because like this you will have 366 days and across 366 days. So 366 into 366 will be the total number of outcomes. And out of these, along the diagonal, they'll have the same birthday. Like, just relate this to that of throwing 2 dice once or throwing a dice 2 times. So we had the same outcomes along the diagonal. We saw the doublets along the diagonal. In the same way here, along the diagonal, you will have 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, 4th Jan, 5th Jan, 31st Jan, 31st Jan, 1st February, 2nd February, 2nd February. Like that, 1st March, 2nd. So like it goes on like that, right? So along the diagonal, you will see that the outcomes will be the same. That is same birthday. So along the diagonal, meaning you will have 366 outcomes along the diagonal, because 1st January, 2nd January, 3rd January, so 366 days, right? So along the diagonal, you will have 366 outcomes. So the probability that both of them will have the same birthday, meaning both the friends will celebrate their birthday on the same day, is 366 favorable out of total 366 into 366. So 1 by 366 is the probability. 1 by 366 is the probability. The total number of outcomes is 366 into 366 for a leap year, 365 into 365 for a non-leap year. For a leap year, it is 366 into 366. For a non-leap year, the total number of outcomes will be 365 into 365. And same outcomes will have, that is doublets, will have along the diagonal. Along the diagonal, we'll have doublets. So doublets is what is the same birthday here. So along the diagonal, in this case, in the case of a leap year, along the diagonal, we'll have 366 outcomes. In the case of a non-leap year, along the diagonal, we'll have 365 outcomes. So probability that the friends will have will celebrate their birthday on the same day. In the case of a leap year, we have 366 into 366 outcomes. Same birthday, meaning same outcomes. That is along the diagonal. So you will have 366 outcomes. So 366 favorable out of 366 into 366. So 1 by 366 is the probability. Different birthdays. So different birthdays will be a total number of outcomes 366 into 366 minus the same birthdays. This will be different birthdays. A total number of outcomes 366 into 366. Take away the outcomes where they have the same birthday. From the total outcomes, take away the outcomes where they have the same birthday. So this remaining will be different birthdays.
Ma'am, or we can use like 1 minus
one
P of P formula number.
Yeah. Sorry? Yeah.
Yes, ma'am.
1 minus 1 by 366.
Yes, ma'am.
Yeah, correct. Divided by total 366 into 366. Different birthdays will be 366 into 366. 366 into 366. This is the total minus same birthdays. So this difference will be different birthdays. So you can take out 366 common. So you will get 366 minus 1 by 366 into 366. Take out 366 common in the numerator. So you will get 366 minus 1. Now this gets cancelled. So we have 365 by 366. So are the probabilities the same for the year 2019? No. For 2019, it will be 1 by 365 for the first one and 364 by 365 for the second one. So for 2019, total 365 into 365. Same birthday, 365 along the diagonal. So diagonal 365 by total 365 into 365. On simplifying, we get 1 by 365. So that is for same birthday. Different birthdays from the total outcomes. From the total outcomes 365 into 365. Take away the outcomes where they have the same birthday. So this will be the number of outcomes where they have different birthdays. From the total number of outcomes, take away the number of outcomes where they have the same birthday. That is along the diagonal. They have the same birthday along the diagonal. So 365 outcomes. Take away that. So this represents the number of outcomes where they have different birthdays. This one by the total number of outcomes, 365 into 365. So take out 365 common. So you get 365 minus 1 in the bracket. So this is how we get 1 by 365 and 364 by 365. We don't get 1 by 365 straight away. We don't get 1 by 365 and 364 by 365 straight away. It doesn't come just like that. It comes after simplifying. It comes after simplifying this. Done, children?
Yes, ma'am.
Yeah, please try and share the answer. Yeah, got it. Who has a better chance?
Ma'am, both have equal chance. Ma'am, no, ma'am, Peter has a better chance. Ma'am.
How do you say that, Navya?
Ma'am, because 1 into 5 and 5 into 1 are also there.
One into
1 into 5 and 5 into 1.
So who has a better chance to get the number 25?
Ma'am, both have equal chance of winning.
Yes, ma'am, both have
equal
equal
chances,
chance.
ma'am.
No, last time I did not take, meaning, no, Navya, yes, Navya.
No,
No,
ma'am,
you thought 5, Navya?
yes, ma'am.
Okay, okay. Yeah, so both have equal chances. Because Peter finds a product and the product is 25 only in this case, 5, 5. And Reena, 5 square, 25. So both have equal chances. I'm not saying that's the answer. I'm just waiting for you to think again. That's not my answer. Both have equal chances. Think. So questions can be tricky like this.
Ma'am?
I'll say you're wrong. That's not the right answer.
Ma'am?
Yeah, yes.
Ma'am, Reena has a higher chance of getting 25.
Okay, yeah, sounds good, but justify.
Ma'am, because the probability of Peter getting 25 is 1 by 18, ma'am. But
1 by 18.
if
Peter, huh?
Peter, yes, ma'am.
1 by 18.
But yes, ma'am.
Why 18?
Ma'am, because he has 2 dice, ma'am. Only if he gets both the numbers as, sorry, ma'am, 1 by 36, ma'am.
No, that's okay. Yeah, okay.
But Reena has a probability of just 1 by 6, ma'am.
Okay, which is greater? 1 by 6 or 1 by 36? Which is greater?
1 by 6, ma'am. So Reena has a higher probability of getting 25.
Correct. All of you think about that. So it's about comparing the fractions. Who has a better chance? So for Peter, 36 outcomes. Out of 36, 1 is favorable for Peter. So for Peter, it is 1 by 36. For Reena, she throws a die. So 6 outcomes. 1 out of that will be favorable. And clearly 1 by 6 is greater than 1 by 36. So Reena has a better chance. Reena has a better chance. Any dispute, you can ask me. Agree, all of you?
Yes.
Yes, ma'am.
Very good. So for Peter, see, 2 dice. So the sample space, 36 outcomes, 1, 1, same thing what we saw in the first case. Yeah, this one. 2 dice. 36 outcomes. And out of the 36 outcomes, only in this outcome, he'll get a product 25. So 1 by 36 is the probability for Peter. For Reena, she throws a die. She throws a die, a single die. So outcomes 1, 2, 3, 4, 5, 6. 6 outcomes. And how many favorable? She squares it. So if she gets 5, 5 square is 25. So that is 1 outcome. 5 is 1 outcome. So this is the probability for Reena. This one is for Peter. Clearly 1 by 6 is greater than 1 by 36. So Reena's chances of getting 25 is greater than Peter's chances of getting 25. All right. Yeah, next one. Find the probability of having 52 Fridays, 53 Fridays, 54 Fridays in a leap year and non-leap year. Meaning you should answer these questions for a leap year and also for a non-leap year. Oh, okay. I think, okay, this only for this one, it is in a leap year and non-leap year. Okay. No, let's take the question like this, children. We'll answer both for a leap year and non-leap year. We'll answer all the three questions for a leap year and a non-leap year. Find the probability. So in a leap year, let me put it like this for you. In a leap year, find the probability of having 52 Fridays, 53 Fridays, 54 Fridays. In a non-leap year, find the probability of having 52 Fridays, 53 Fridays, 54 Fridays. We'll answer all the three subdivisions for a leap year and a non-leap year. Let's not take it like this. Answering only this for both. Let's not take it like, it's not like that actually. I think I'll just change the question. In a leap year, find the probability of having 52 Fridays, 53 Fridays, 54 Fridays. Then we'll answer the question for a non-leap year also. All these for a non-leap year. Yeah. Yes, children. No hurry, think and let me know.
Ma'am?
Yeah.
Ma'am, in a non-leap year, we have.
Sorry, Sashank, we'll answer these questions first for a leap year. Sashank, please answer these questions. See, in a leap year, find the probability of having 52 Fridays. Yeah, tell me.
Ma'am, in a leap year, we have 52 weeks and 2 days extra.
Correct.
So we can confirm that there will be 52 Fridays for sure.
Very good.
Ma'am, we have the probability can be 54 by 36, 365 number.
So a leap year has 366 days. That is 364 days plus 2 days. So 364 days is 52 weeks. 52 into 7 days plus 2 days. So 52 into 7 days is 52 weeks plus 2 days. So since every year, whether it is a leap year or a non-leap year, every year has 52 weeks. Every year has 52 weeks, which means there will be 52 Sundays, 52 Mondays, 52 Tuesdays. Every day of the week will happen 52 times in every year. Whether it is a leap year or non-leap year, every year will have 52 Sundays, 52 Mondays, 52 Tuesdays, 52 Wednesdays, Thursdays, Fridays, and Saturdays. So the probability of 52 Fridays in a leap year is a sure event. Is a sure event, which means the probability is
1.
1. Now for 53 Fridays, it depends on these 2 extra days. 52 Fridays, yeah, 52 Fridays we definitely have. To have that extra Friday, that 53rd Friday, now these 2 days can be a Sunday, Monday. The 2 days, these 2 days can be a Sunday, Monday, or it can be a Monday, Tuesday, or it can be a Tuesday, Wednesday, or it can be a Wednesday, Thursday. Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday. It can be a Wednesday, Thursday, or it can be a Thursday, Friday. It can be a Friday, Saturday, or it can be a Saturday, Saturday, Sunday. The 2 days can be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or a Saturday, Sunday. So supposing the 364th day, supposing the 364th day was a Wednesday, then Thursday, Friday. The next day will be a Thursday, the next day, Friday. Or if the 364th day was a Thursday, then next day, Friday, then next Saturday. So here we can make 7 possibilities. 1, 2, 3, 4, 5, 6, 7 possibilities. Out of this, 2 are favorable. This one and this one. So the probability of having 53 Fridays, because that depends only on these 2 days. And these 2 days can be any one of these combinations. Can be any one of these combinations. So here in these 2, we have Friday. So 2 out of 7. 2 out of 7 is the probability. We have made combinations for the 2 days. So like we are able to make 7 possibilities for the 2 days. Of this, favorable is 2. Thursday, Friday, or Friday, Saturday. So 2 out of 7 is the probability. What about for 54 Fridays?
0, ma'am.
0. It's impossible. Any day of the week you can have up to 53. 54 is impossible. Because for 54 you need to have 54 into 7. 7 4s are 28, 8 2 carried over. 35, 36, 37, 378 days. Let's answer the same questions for a leap year. I'm sorry, for a non-leap year. So 52 is a sure event. Since there are 52 weeks, we'll definitely have 52 Fridays. 53 Fridays depends on that one extra day. Not extra day, that last day, that one day. That one day can be a Sunday, or it can be a Monday, or it can be a Tuesday, or a Wednesday, or a Thursday, Friday, Saturday. So if that one day is a Friday, then there'll be 53 Fridays. So it is 1 out of 7. There are 7 possibilities. Out of that, 1 is favorable. There are 7 possibilities. Out of that, 1 is favorable. So 1 by 7 is the probability of having 53 Fridays. 54 Fridays, impossible event. Yeah, we'll just try this one and wind up the session for today. If all the number cards of spades and face cards of black are removed from a pack of 52 cards. Okay. So a deck of cards, a pack of playing cards has 52 cards, 52 cards, 26 red cards and 26 black cards. $52 cards. There are 4 suits. There are 4 suits. 2 black suits and 2 red suits. The black suits are spade and club. Red, heart and diamond, or hearts and diamonds. $52 cards, 4 suits, 2 black suits and 2 red suits. The black suits are spade and club. Red suits, heart and diamond. Now 52 by 4 is 13. So each suit has 13 cards. And of the 13 cards, it's 9 plus 4. 9 number cards. Okay, it's 9 plus 3 plus 1. 9 number cards, 3 picture cards, 1 ace card. 1 ace card. $52 cards, 52 by 4, 13 cards in each suit. 13 is 9 plus 3 plus 1. 9 number cards, 3 picture cards, 1 ace card. The picture cards are king, queen, and jack, because you can see the face of the king, face of the queen, and face of the jack. So picture cards or face cards. Face cards or picture cards, because you can see the face of the king, queen, and jack. 9 number cards. 3 face or picture cards, 1 ace card. So like this, 9 plus 3, 12 plus 1, 13. 13 in each suit. Like this in 4 suits, 13 fours are 52. 2 black suits, 2 red suits. Jokers not included. Yeah, that's what you see here. Remember this term honor cards also. Honor includes the aces. If it is picture or face cards, if it is picture or face cards, it's only the kings, queens, and jacks. Honor cards includes the aces also. Okay, I'll just share this image on WhatsApp. I'll just alter this presentation, meaning this is very faintly visible. So I'll just change this and share this image on WhatsApp. So don't bother to write it now. I think it's clear. So I told you each suit, we'll talk about one suit which has 13 cards, 9 number cards. The numbers are 2, 3, 4, 5, 6, 7, 8, 9, and 10. There is no 1. 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the numbers on the cards. 2, 3, 4, 5, 6, 7, 8, 9, 10. This totals to 9 cards. 9 number cards. King, queen, jack. Face or picture cards. Ace card. All these 4 honor cards. Honor. Picture cards, only these 3. So these are the suits, the symbols are spade, club, heart, and diamond. So you can see these are the red cards. Diamond and heart, red cards. Spade and clubs. Spade and club, black cards. You can see the ace here. 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, and king. So you can see their faces. King, queen, jack, you can see their faces. Face or picture cards. This is the ace. Okay. Yeah, answer this one.
Ma'am, it's 1 by 4 and 3 by 40.
It's only one answer.
Ma'am, was it 7 by 18?
Yeah, 1 second. No, even I'm just working on it. If all the number cards of spades and face cards of black are removed, all the number cards, so this one is, all the number cards of spades are removed. So that means 9 is removed. So what remains? 4 remains here.
Is it 11 by 37?
Okay, I'll note your answer. 11 by 37. Okay. I'll note your answer. Yes. So if all the number cards of spades, all the numbers, 9 number cards are removed. Of spades, spade is one suit. All the number cards, so 9 cards are removed. So 13 minus 9, 4 are here. And the face cards of black. So face cards of black meaning the number cards are removed of spade and the face cards are also removed of spade. So there's only one ace. In spade, there's only that ace card. Because these two are black suits. So in the club, all the face cards are removed. So 9 number cards plus 1 ace card, that remains. Black is both of them. Black is both spade and club. All the face cards of black are removed. 9 plus 3 plus 1. Here also 9 plus 3 plus 1. 9 number cards, 3 picture cards, 1 ace card. All the number cards of spades removed. Face cards of black, that means removed. From a pack of, I hope it's clear. 9 plus 3 plus 1. All the number cards of spades, so 9 gone. And face cards of black. So black meaning both spade and club. Only face cards of both black. Sorry, face cards of black, meaning 3 here and 3 here gone. So 9 plus 3 plus 3 removed. 12 plus 3, 15. So from 52, 15 is removed. So 36, 37 cards remain. Now the denominator will be 37 because the total number of cards now is 37. It's not 52 anymore. The denominator is 37 now. Now, what's the probability of picking a card that's a black card or a 7? It can be a black card, any black card or 7. So here in spade, we don't have 7. Because 7 is removed, the number card is removed, 7 is not there. It can be a black card. So there's 1 here. Here, 7 or a black card. So how many here, children?
10.
It can be a 7 or a black card. Quick, quick. From spades, children, from spade you have 1. Because it can be a black card also. It can be a black card. So there is 1 in spade. Ace you have in spade. And in club, club is also a black card. So don't you think you have all the 10?
Yes, ma'am.
Yes.
And then do you have a 7 of heart?
Yes.
Heart is a red card. Heart is a red card. But there's a 7 there, right?
Yes.
Here also there's a 7. So this is 1 card. This is 1 card. So how many in all? Yeah, tell me the favorable number of favorable cards here.
25, ma'am.
Sorry? 7 is 1 card.
13, ma'am.
13.
Yeah. 13. All of you agree?
Yes, ma'am.
13 by 37. 37 was right because 15 cards are removed. 37 is right. The card you pick can be a black card or a 7. Both are fine. If it's a black card, fine. If it's a 7, fine. Both are fine. Black card, good. 7 also good. Black card or a 7. So spade is a black card. So there we have 1. Clubs, black card. Any black card is fine. Not 7. Any black card is fine. So here you have 10. And then from heart and diamond, you have 7. 7 of hearts and 7 of diamond. So 1, 2, 3, and 13. 13 by 37.
Ma'am, I missed the 7 while counting.
Ah, okay. From the red cards, right?
No, ma'am, I did not read after the black card.
Oh, okay. All right, okay. Class, use the emoji, raise your hand. Navya, Sashank, Madhumita, Florentina, Krishrutik, Arjun, Krishmi, and Raja. Yeah. All right, children. That's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you.
Thank you, children.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.